Review generative outcomes. In this video, we'll explore generative outcomes. In Fusion 360, we want to carry on with our additive bracket. Now, at this point, if your solve is still continuing to produce outcomes, you will see that it's still working on those solves. But if it's completed, you'll see a green check mark here. Again, you can follow along and you can explore those outcomes as they're being generated, but that process does take a bit of time. Making sure that we limit the number of load cases, manufacturing methods, and materials can help speed up that process. But let's go ahead and dive into Explore and take a look at some of the outcomes. When we're working in Explore, there is a lot of different information that we can take a look at. First, when we're presented with the Explore outcomes on the screen, we have some recommendations. Recommended outcomes are based on things like visual similarity and whether or not they converged or completed. You'll notice that we have 3 studies here that have converged, which means that they were able to meet the criteria or the requirements that we set forth in the design. And we have 1 here that's completed, which means that it has finished creating the iterations that it's going to, but it doesn't necessarily meet the design objectives that we set forth. One thing that we can do is we can take these recommendations and go ahead and just compare them, or we can dive a little bit deeper before we decide that these are the best 4 options. Generally, the recommended outcomes are going to be pretty good in terms of differentiating between all the other outcomes that we have. And if there are a lot that have visual similarities, it'll filter down and look for the best one. But we can extrapolate the data a bit more by taking a look at their properties, taking a look at a scatter plot view and identifying things like the factor of safety, whether or not these are inside of our recommended outcomes, and whether or not they fall outside of some of our ranges. For example, you can see that the real sand material is up here in the upper right, and this really did not produce very much at all. It only went through 4 iterations, and this is its final. It didn't meet the factor of safety limit. It's still at 9.57, which is well above what we need, but that's just where it completed its process. Now, there are other options down here in different orientations where we can see X minus, we can see the unrestricted method, but this one up here that was in X plus just did not produce good results. And you'll find that is the case whenever we're dealing with additive manufacturing or casting and we set up these different orientations, which is exactly why it's good for us to include multiple orientations, especially if we're not sure how we're going to set up the print in a machine. We also have a table view, which gives us all the required information, and it just simply displays it without the large, in this case, the thumbnails that we would see on the main pages. Depending on how you like to look at your data, you can always go back and forth between them, and you can even sort inside of here. And in this case, you can see that we have study, visual similarity, recommendations, and so on, but by default, it's going to sort by processing status. One thing that I like to do is take a look at visual similarity. We can see here that group 1, these two are very similar. And if we take a look at the ones up here, you can see that these are all unique. So these options that are unique have been identified as good or viable for our outcomes. But that doesn't necessarily mean those are the ones that we want to choose. So just keep in mind that a lot of time can be spent here identifying some of the better options. On the left-hand side, there are some additional filters that we can use. For example, if we want to take a look at only items that have converged, we can either deselect the completed ones or we can isolate the converged ones. We can also go down and take a look if we have multiple studies running, if we have visual similarity, and we want to take a look at only certain groups. The design file will organize these if any of them have already generated an outcome, whether it's a design or a mesh. We also have manufacturing methods. If I don't really like the way that the additive ones were looking, I can turn those off and focus my attention solely on the unrestricted. But in this case, for example, structural study 1, outcome 32, this is not one of the ones that is an unrestricted method. It's actually an additive method. So as we go through here and we take a look, you can also see additional icons. The thumbs up is one of the recommended solutions. The one that has a small icon indicates that a design has already been created. And structural study 1, outcome 30 was one that I chose to create a 3D design from. But in this example, as we're going through, I want to compare outcome 32 and outcome 30. And I'm going to select the checkbox in the upper left-hand corner for those two. And then I want to use the icon to compare them. As stated, outcome 30 has already been used to create a design. And as we look at the difference between them, we can see that the orientation for the one on the left is Z plus, and it's using the HP Jet Fusion material, and the one on the right is X plus. So as we look at it, X plus in our case is facing forward or away from the wall, and Z plus is facing up or away from the shelf. Now, the orientation of these, because they are 90 degrees apart, produce very similar results. We can see that the Z plus orientation has produced a lot of material underneath the shelf area. But the design, or at least the lattice work that's inside of here, is a little bit more appealing than the one on the right because it has this sort of blocked in section. Again, these are all things that we can adjust and work with, but just keeping in mind that there are some differences between the two that might help you decide one over the other. I'm going to close outcome 32 and I'm going to take a look at this one here. Note that we can also go back earlier in the process and focus on earlier iterations. For example, at some point in time before these openings were starting to be created, if we want to create our own internal lattice, outcome 34 might be a great option. We can take this and we can generate a design directly from this. Now, if we decide to do that, we can select Create Design from Outcome. It'll begin preparing that design, and once it's ready, we'll have a green icon in the upper left that allow us to open that in Fusion 360. Also note that inside of the bottom timeline area where the iterations are listed, it shows exactly which iterations were used to create that outcome. So note that we don't necessarily have to always go to the last iteration. In some cases, we might want to go back to an earlier iteration if it means that the post-processing is going to be a little easier. One thing we'll note is that the factor of safety limit for iteration 34 is still at 2, and we can take a look at the mass, 0.016, and we can take a look at other values such as the stress. If we go all the way to the end, we can see that the stress is still the same, the mass is relatively similar, and the factor of safety is also the same, it's still 2. So we're not really seeing very much difference except for the displacement. We're seeing 3.88 millimeters on this earlier iteration without the lattice work on the inside, and the last iteration actually has a lower displacement value at 3.22. So again, it just depends on what the outcome is that you're looking for and whether or not you're going to be post-processing this, because sometimes going back just a little bit, maybe before some geometry was created, can be a better option. As we look at this design and we take a look at the stress view, the stress references will show areas of ideal stress, high stress, and low. Now, we're going to have low stress all the time on this back plate because we fixed it in space. So it's not really going to change this back face. However, we did load the top, and you can see that the stress concentration is mimicking the actual shape underneath that plate. So as we look at this design, this gives us a good ideal situation. It just continued to explore further iterations, removing material and making sure that it got to the most idealized version. Keep in mind that the objectives and the limits that were set up for this study were only looking at the factor of safety. We weren't looking at a target mass or minimizing deflection or any of those other criteria. So it's solely looking at that one metric, which was the factor of safety. This makes it a bit easier for it to focus on that one metric and not have to worry about things like max displacement, other than the fact that it's calculating it and it's giving us that result. At this point, we have generated an outcome from this design as both a 3D design and a mesh that will be provided in the next video. But if you want to continue to explore, note that you can always go back and go through any of these outcomes. You can use the filters, you can look through the designs, and even while we're here in the thumbnail view, you can hover the cursor over the earlier iterations and you can see how the build progressed. So as we look, they all started out very similar. It started removing material from the sides and it began creating that sort of lattice structure inside until it got to that final step. You ultimately will have to make the decision on whether or not you want to solve your study and export your own designs, But once again, they will be provided to you, so you don't necessarily have to. If you've made any changes to the design, as always, make sure that you do save them before moving on to the next step.